Let's look at the investigation question from January 2021. So it says the diagram below shows a sequence of figures made up of circles with dots. Each figure has one dot at the center and four dots on the circumference of each circle. The radius of the first circle is 1 unit. The radius of each new circle is 1 unit greater than the radius of the previous circle. Except for the first figure, a portion of each of the other figures is shaded. All right, so as you can see, it kind of looks like a target. Anyway, complete the rows in the table below for figure 5 and figure N. All right, so let's see what that would be. So whenever you're looking at an investigation question, you first need to look at the rows and columns to make sense of what is being described in the table, right? So here it says you have your figure number, so figure number 1, 2, 3, all the way to n, and then you have the number of dots in each figure, the area of the outer largest circle, the area of the shaded region, and the total length of circumference of all circles. So here's what you do. Now there's a relationship between the figure number and the number of dots, the figure number and the area of the outer circle, the figure number and the area of the shaded region, and so on, right? So there's a relationship between the figure number and all of those. And that's how we get n as the figure number to come up with a generalized rule. So first things first, what we're going to look at is we're going to try to, well, let's fill out the most obvious things first, right? So here we are going in sequence 1, 2, 3, 4, 5, and as you can see, the number of dots, so it's 5, 9, 13, 17. So 5 plus 4 is 9, 9 plus 4 is 13, 13 plus 4 is 17, and then 17 plus 4 is 21. Fine. And then over here, we have pi, 3 pi, 5 pi, 7 pi. So that is, it seems to be going up in twos. So then the next one should be 9 pi. And then the total length of the circumference of all circles, you have 2 pi, and then you have 6 pi, 12 pi, 20 pi. So this seems as it's going up. Well, 2 plus 4 is 6, 6 plus 6 is 12, 12 plus 8 is 20. So then that's 4, 6, 8. I expect the next one to be plus 10, right? So then this would be 30 pi. So that's the first one for 3 marks. Now let's try to generalize this rule. In order to generalize the rule to come up with what is the rule to get the number of dots in any of the figure numbers if you know what the figure number is. Here's how you do it. You think of you look for the common difference between each each new figure number and the number of dots. So like for instance, each new figure number here is you're adding 4, right? So 5 plus 4 is 9, 9 plus 4 is 13, 13 plus 4 is 17, 17 plus 4 is 21. So it means then that the relationship between the figure number and the number of dots has to do with 4 times the figure number plus or minus a value. So let's just say to get n, right, it's going to be 4 times n plus some value. Let's call that value d is equal to the number of dots, right? Well, actually, let's call the value x instead, right? Because if we call it x, then I can then write the number of dots as d, right? It doesn't matter though, it's just a variable, so you could choose any variable you want. So 4n plus, let's say x. Oops, I used the wrong tool there. 4n plus x is equal to the number of dots d. Well, let's substitute some values in there. So let's use when the figure number is 1. So when the figure number is 1, that would be 4 times 1 plus some value x is equal to the number of dots, which is 5. I'm using this one here, okay? The first one. Well, then that would mean x is equal to 5 take away 4, which means x is 1. Well, let's see if that would hold true for each of these figure numbers and their number of dots. Well, if we think about when it's 2, 4 times 2 is 8, and 8 plus 1 is 9. When it's 3, 4 times 3 is 12, and 12 plus 1 is 13. When it's 4, 4 times 4 is 16, plus 1 is 17. And when it's 5, 4 times 5 is 20, and 20 plus 1 is 21. So it seems as though this really is the rule. So I can generalize that rule as 4n plus 1, and that gives me the number of dots. Now for the area of the outer largest circle. Let's see what's happening here. Well, here it's pi, then 4 pi, then 9 pi, then 16 pi, then 25 pi. As you can see, these 4, 9, 16, and 25, and well, here is 1, is already 1 pi, right? These are all square numbers. So it seems, it would appear that to get the area of the outer largest circle, we will square the figure number. Look, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. So then the generalization of that rule will be whatever the figure number is, n raised to the power of 2, n squared. That gives us the area of the outer largest circle. All right, let's look at the other one, the area of the shaded region. What's happening here? The common difference here is 2, right? Because 1 plus 2 is 3, 3 plus 2 is 5, 5 plus 2 is 7, 7 plus 2 is 9. So it means that the generalization of this rule is going to be 2 times n, the figure number, plus or minus some value. Well, let's figure it out. So it's going to be, let's say it's 2n plus some value, let's call it x again, is equal to a, the area, right? Well, substituting some values from the actual table here, let's use 2, right? So when the figure number is 2, so when n is 2, that means 2 times 2 plus that value x is equal to the area of the shaded region when n is 2. That's 3 pi, right? So I'm just going to put 3 in this case because pi is a variable, so we don't really need to use it there. So let's see, this would be 4 plus x is equal to 3, which means x is equal to 3 take away 4, which is negative 1. So therefore, by my calculations, the rule should be 2n take away 1 gives me the area of the shaded region. And let's put that to the test. Well, if n is 1, 2 times 1 is 1, so it works for here. If n is 2, 2 times 2 minus 1 is 3. If n is 3, that will be 2 times 3, which is 6. Take away 1 is 5, so it works there. 2 times 4 is 8, and 8 take away 1 is 7. It works here. And then 2 times 5 is 10, and 10 take away 1 is 9. So it does work, and therefore I can generalize the rule as 2n minus 1. Now the last one, let me just clean this up a little bit, right? Just because now we have our values, so I can just get a little cumbersome here. So I'm going to clean it up a little bit. Right. So now we're going to look for the generalization for the last one. Now the last one is to the total length of circumference of all the circles. So you have 2, yes, you have 2, 6, 12, and 20, and then 30. So it seems as though it's a double. You're adding two more to the previous, well, whatever you added before, meaning like, so 2 plus 4 is 6, and then to get from 6 to 12, that's plus 6. So the new difference is 4 plus 2. And then the other one is 8, because 12 to 20 is 8. So that's 6 plus 2 is 8. And then the last one, I assume, would be 10, right? Because 8 plus 2 is 10. But also 20 to 30 is 10. When you have a double difference like that, because you're adding to the previous amount that you added before, this is when it has to do with you're going to be squaring the figure number. It's squaring the figure number. The relationship is going to be squaring the figure number and adding some value, right? So it's kind of like, for me, I find it's kind of like trial and error, right? So I know it's going to be n squared and plus something or minus something, right? So if I look at each of them, if it's n squared, n here is 1, right? Because that's n is the figure number. So that would be, if it's n squared, so that would be 1 squared, and 1 squared is 1. 1 plus 1 is 2. When n is 2, right, that would be 2 squared, and 2 squared plus 2 is 4. If when n is 3, because this is the third figure number here, that would be 3 squared, and 3 squared is 9. 9 plus 3 is 12, right? Um, And then here, when n here is 4, so that's 4 squared, which is 16, and 16 plus 4 is 20. And then finally, when n is 5, that's 5 squared, and 5 squared plus 5 is 30. So as you can see, the general rule for this last one is n squared plus n. And that's how you would figure out the total length of circumference of all the circles. So it is a little bit of trial and error, but not like by just arbitrary, just adding something arbitrary or taking away something arbitrary. There's a bit of a strategy here. The strategy is, if there is one common difference, as in the case with the number of dots when the common difference was 4, or in the case with the area of the shaded region when the common difference was 2. It means for each new one you would just add in like one value, right? It's a linear relationship between between the figure number and the area, or the area of the larger circle, or the area of the shaded region. But when you have like a double kind of common difference, meaning that with each difference you're gonna add something else. It's a quadratic type of relationship that you're looking for. So it's going to be the figure number squared plus or minus something. And you just use the values and see what is the constant there that you're adding, or what's the thing that you're repeating. Let's move on to the other part of the question. Determine the value of n when the number of dots in figure n is 541. So let's just go back to look at what is the relationship. The number of dots is defined as 4n plus 1. I'm gonna just change this um, pen. I don't like how thick it's writing. Yeah, so the number of dots is found by 4n plus 1. So that's 4n plus 1 is equal to 541, because that's what this question is telling us. The number of dots is 541. So if the number of dots is 541, it means 4 times whatever n is plus 1 is 541. So this would be 4n is equal to 540. And so n will be 540 divided by 4. That would give me my answer. 540 divided by 4. Let's see what that is. 540 divided by 4. 135. So that means that when your figure number is 135, your number of dots will be 541. And then the final part of the question, write down in terms of p and pi the area of the largest circle in figure 3p. All right, well, let's see. If the area of the largest circle is given as n squared, right? So the largest circle, the formula to find that is n squared. So if the figure number is 3p, it means, so let's n equal 3p, right? So, oh, you know what? Sorry, I forgot something. There should have been n squared by pi. I forgot the pi part of it because the n squared is the figure number squared multiplied by pi. So it should be n squared pi. That is the formula to get the largest circle. So then, if we're looking at figure 3p, it means n, which is typically the figure number, is actually 3p in this case. And so the largest circle would be 3p squared. Sorry, my pen just malfunctioned there. So yeah, it will be 3p squared times pi. Oh, you know what? I made a mistake. Sorry. Because if n is 3p, that is interesting. Let me write that back. And that's a valuable mistake to make because I could really show you all how to substitute it properly here. So you're going to substitute n is equal to 3p into n squared by pi. So wherever you have n, you're going to replace it with 3p. So that should really look like 3p all to be squared by pi, which would be 3p times 3p, which is 9p squared times pi. And that is your answer. Not just 3p squared, but it'll be 9p squared because 3p is n. So if I'm substituting 3p for n into n squared, it means 3p has to be multiplied by 3p. So it's not just 3 by p squared, but it's 3p times 3p.